Now we'll talk about and or statements. Let's say we're being asked to find the probability of A and B. Another way we could write this is just PAB, means that both A and B must happen for success. So when we go back to this other example, a spade and a jack, if we have a card that's a spade but not a jack, it's not good enough. If we have a card that's a jack but not a spade, that's also not good enough. Both things need to happen in order for it to work. Now when we get to the word or has a slightly different meaning in a math context than it does in an everyday life English context. When we say probability of A or B, it means that A could happen, or B could happen, or both A and B can happen for success. When we use or in regular English, generally we use an exclusive or, meaning just A or just B, and we get rid of the part where it could be A and B. In math, we use what's called an inclusive or. But people do use inclusive or in English sometimes to make jokes. Here are some examples. If somebody's saying, do sharks play harmonica like this or this? And somebody answers yes, meaning both of these are correct. Or, is this one of these 3 video games, this weird situation? And somebody's just saying yes. Now that we've seen and in or statements, we can talk about the addition rule. The addition rule tells us the probability of A or B is equal to the probability of A plus the probability of B minus the probability of both A and B. Now we'll look at an example. One card is drawn from a standard deck. Find the probability that the card is a jack or a spade. So we know our probability of getting a jack is going to be 4 out of 52, and we've found our probability of getting a spade is 13 out of 52. So we have 4 cards that are jacks, we have 13 cards that are spades. If we use our formula, our probability of getting a card that's a jack or a spade, we would add up the probability of getting a jack to the probability of getting a spade. And then now we need to subtract the probability that they happen together, which we found was 1 out of 52. And we end up with 16 out of 52. Now the reason that we have to use this formula or make sure that we do the subtraction over here is because the jack of spades, which is the one card that's both a jack and a spade, is included in the group of 13 spades, and it's included in the group of 4 jacks. So if we didn't subtract this, we would be counting the jack of spades 2 times, and our probability would be too high. Now let's look at another example. Suppose in a parallel universe where Blockbuster is still around, a particular Blockbuster has movies that are rated G, PG, PG-13, and R with the following probabilities. So they have a lot of movies. If you rent one at random, your probability of getting a G-rated movie is 0.35, probability of getting a PG movie is 0.2, PG-13, 0.3, probability of getting an R-rated movie would be 0.1. Now we're being asked, if you select a video at random, find the probability that it is either G or PG. So if we use our addition rule, it would be probability of G plus probability of getting a movie that's PG minus the probability of getting both. Now this is going to come out to 0.55 because we can't get a movie that's both G and PG at the same time, so this probability would end up being 0. They can't happen together. You can only get a movie that's G or PG. A movie can't simultaneously have 2 ratings. Let's look at the next example. Find the probability that a card selected at random is not rated G. We could use the rule about complements here to solve this one. So this would be 1 minus the probability of getting a movie that's G is equal to the probability of the complement of G, which is what they're asking us for. So it would be 1 minus 0.35 is equal to 0.65. Part C is saying we want to find the probability that we select a video at random. It's not G or PG-13 or R. This is a tricky complement, so we want to do 1 minus the probability that it's G or PG. So this will be equal to 1 minus the sum of all of these. And we get 0.05. Now I know this seems like a weird example because we might think, well, shouldn't it be a 0% chance of not getting a movie with one of these ratings, but there are other ratings that can exist. You have movies that are not rated. You have movies that are rated NC-17. There are other things besides these 4 ratings here. They never told us these were the only possibilities. They just gave us some of the possibilities. Or they told us we have these possibilities, but they didn't tell us that there weren't more. So we can't necessarily assume that. And we see that there's a 5% chance of getting a movie that doesn't have one of these 4 ratings. Now let's look at another example. One card is drawn from a standard deck. Find the probability that the card drawn is A, a king or a queen, B, a king and a queen. Here I would suggest pausing the video, try to work through it on your own, then hit play to see me go through the answers. So the probability of getting a king or a queen, probability of getting a king plus probability of getting a queen minus probability of getting a king and a queen. So this would just be 4 out of 52 plus 4 out of 52. We have 4 kings, we have 4 queens. You don't have any cards that are kings and queens, so this would be 8 out of 52. And we've kind of answered part B here. There are no cards that are both kings and queens, so our probability here would be 0% or just 0. We can't get a card that's both a king and a queen, even if you have some set of playing cards that's like themed on RuPaul's Drag Race or something. You can't argue you have a card that's both a king and a queen. So this would have a 0% chance and be something that's considered impossible. So to talk more about things that are impossible like that, or when you have 2 events that can't occur together at the same time, these events would be called mutually exclusive. This means the 2 or more events can't happen simultaneously in one iteration of the experiment. If A and B are mutually exclusive, the probability of them happening together is 0. So like in this last example here, getting a king and queen at the same time would be mutually exclusive. Now let's look at this example. In which choice are A and B mutually exclusive events? Our first choice, we're told the experiment is 2 coins being flipped. Event A, the first coin lands on heads. Event B, the second coin lands on heads. This is something that can happen if we flip 2 coins. You can have both coins land on heads, so this wouldn't be mutually exclusive events. B, experiment. We draw 1 card from the deck. Event A, the card is red. Event B, the card is a queen. We do have 2 red queens in the deck. The Queen of Hearts and the Queen of Diamonds are red, so this wouldn't work. So these are 2 red queens, or 2 examples of being able to get a card that is both red and a queen at the same time, so these events would not be mutually exclusive. C, experiment, roll 1 6-sided die. Event A, land on an even number. Event B, land on an odd number. We can't have a number that's both even and odd at the same time, so this would be mutually exclusive events. Right? So a number can't be even and odd at the same time. And we'll look at the last choice just to see why this isn't an example of mutually exclusive events. Draw 1 card from the deck. A, the card is a club. B, the card is black. We have a whole bunch of cards that are both clubs and blacks. Actually, every club is black. So these would not be mutually exclusive events because they can happen together.